afternoon, everybody. And for those people joining from Chicago or San Francisco, good morning. And then potentially this evening for folks elsewhere. Thanks for joining us for 16th Cassandra Lunch. This is something that we do on a weekly basis. Actually, I should change that. Today's topic is not diagnosing Cassandra issues. It is backup and restore. We have a couple of co-organizers. You can contact us if you'd like to speak on a topic related to Cassandra, or if you want to be a co-organizer with us. Always need people to help. We're part of a larger data community DC that embraces inclusiveness from all people from all backgrounds. We're part of a much bigger group, as I mentioned. We're actually a collection of several groups primarily related to data. In this group, we cover Cassandra variants, things that talk to Cassandra, how to deploy Cassandra, how to deploy platforms that involve Cassandra, you name it. As long as we're dealing with CQL at some point, we're covering it. Even if it's not Apache Cassandra, we'll talk about it. I don't see anybody new. I think most of us are regular attendees. Otherwise, we would ask you to introduce yourself. Group rules, if you have a question, just ask it on chat or ask it on the, just politely ask during the middle of the conversation. DataStax is one of our sponsors. They help us get the word out. They also have been a great sponsor when we were doing in-person meetings. GW is a sponsor also for our venue space during physical meetings. Hopefully we get there sooner than later. Some of our sponsors from DC and Chicago. I just updated this, but this is a more current version of our organizational sponsor list. As you can see, we added General Assembly, Capital One, Data Society, and American University. Unfortunately, Booz Allen and AOL have not renewed their organizational sponsorship. Any announcements? Any upcoming events?
Yeah, there's a webinar tonight at 6 p.m. If you go to anant.us/events, you'll be able to see it. It's on Spark and Cassandra. It's more of an introductory about what Spark is, and then we're going to be doing a demo showing you how you can do SQL on top of a NoSQL database like Cassandra.
Cool. Yeah, there's a couple of other. Yeah, go ahead.
Yeah, tomorrow there's also going to be another webinar at 6 p.m. I'll be just doing a little introduction to using Terraform to get Kubernetes up and running on AWS. Similar to the one tonight, it's going to be just a quick introduction, introducing you to Kubernetes, what it is, what it does, go through a few use cases, and showing you a demo of how to just get up and running using Terraform.
Sweet. Looks like there's another one coming up next week, which is an extension of that. Yes,
I'll be building on my series. In the first one, I got Cassandra up with Terraform, and now I'll be combining both Cassandra and Kubernetes to kind of just show you, what you're able to do.
Awesome. Very cool. Excited? Let's get right into it. Today's topic, as I mentioned, will be primarily on backup and restoration. One of the biggest questions I get in, when I consult with clients or people learning Cassandra, how does backup work in Cassandra? Well, one of the first places to go is to take a look at Cassandra.Apache.org, right? And it talks about how it works. There's also, that's the native backup strategy. I'll go deeper into that. There's another strategy that if you're using a cloud provider like AWS and your disks are using something like EBS, which is elastic block storage, those drives, those virtual drives that are attached are snapshotted, and that's called an EBS snapshot. That's different from a Cassandra snapshot, and that's one way to do it. And generally, you can find resources on how to use Cassandra backup, or you can use, you can get strategies of as a video on how to do that. So I'll just outline the major strategies so we can walk through it. So the number one strategy is to have everything up and running, okay? Multi-data center, multi-region, maybe even multi-cloud, okay? What does that mean? That means that regardless of, like a whole, so what multi-data center means, like US East plus US West, right? 2 data centers. Or in here, we'll say US East in availability zone 1, A, B, and C, meaning organizing the racks and the nodes in a way that even if the availability zone gets lost in US East, it's still up and running, okay? Multi-cloud would be, so this is all in the AWS, right? This is the region. And this is availability zone. Right? But you can also do multi-cloud, which is you can have Google, and then you can have, US East here, or whatever they call it, right? And that could be one cluster. 2 data centers in AWS, 2 data centers in Google. It's possible. So if AWS goes down, Google's there. But having the ability to be up and running doesn't solve the problem of somebody going in there and actually deleting data. So human error or human sabotage. What happens if somebody goes and deletes the data? How do we recover from that? So this is great for disaster avoidance, but if disaster does happen, then we're basically talking about right? So this is disaster avoidance, but then disaster recovery is what we're talking about, backup and restore. So we talk about native, backup / restore. Then there is cloud native, cloud IaaS snapshot / restore. And the third one is where we do kind of like a combination, where we do Cassandra backup plus upload to distributed file system like S3. Okay. There are some tools that help with this. You can Google Cassandra Toolkit, and we actually outline it. Op Center is now only exclusive to DataStax. It used to be able to work with open source, but Op Center has a backup and restore, which is, I'll just say, this is 1, this is 2. So Op Center basically does 1, 2, or 1 and 2. So you can store the snapshot. It uses the same tool. It snapshots it locally, and it can restore locally. Or it can do this, or it can do both. Another one is called TableSnap, and TableSnap just does one, and then, I want to correct myself. It does 1, 3, and then 1 and 3. So TableSnap basically takes it and puts it into S3 or whatever, I think it supports S3. And another one that came out recently is called Medusa, Cassandra Medusa. He keeps trying to ping me on something. Sorry about that, guys. And Cassandra Medusa is kind of like the same thing as Offsetter, but it works with open source. So 1, 3, and I think 1 and 3. We'll take a look at this. The challenge with backing up Cassandra is that we're not just backing up for one computer, we're backing up for potentially many, many, many computers. Okay. But I think it's actually easier. Like once you understand how the backup process works, I think it's much easier than another database. And the secret is that the backup of the data is the actual data. So if you screw up, if you have the backup of the data, you literally just copy and you put it back to where your original data was, and you restart the nodes and you do a repair, and you have all your data back. That's it. So snapshot, a Cassandra snapshot basically means that it copied the data as it was at that time over. So take a look at the Cassandra documentation and see what we get there. So snapshot backup is the one that I'm talking about. There's also another thing called incremental backup. And there are settings where you can, say do an auto snapshot when you do a truncate, for example, or do a snapshot when we do a compaction. Compaction means that we're cleaning up and merging SS tables. So go ahead and do a snapshot there. And what happens with a snapshot is that, well, before we talk about snapshot, is that the data in Cassandra, there's a data folder that we configure. In there, there's a Keyspace where a bunch of tables are, and then there's a table directory, right? So the SS table files for that Cassandra table are all in here. And of course, this is on every machine will have this kind of structure, right? And each machine will have different SS tables, because if we have different replicas, not every machine is going to have the same SS table data. Okay, so when we do a snapshot, it basically does a link at that time in this directory from what's here. And as things get added here and snapshotted again, it continues to add these references back to the original files. And even if this stuff is deleted, you won't lose this data, because they do a linking. There's different types of linking in Linux, but it's a type of linking where you'll have this data here. Now, if you take this is still on the same disk, right? So if you take this data and you back that up, even if this whole machine was completely destroyed, you still have the information. Except you won't have the configuration. So that's why, Eric, you asked, can you back up the whole deployment? So that's the other thing that you have to think about, is not just backing up the data, but also backing up the configuration, and that's in a different directory.
Correct.
Yeah, go ahead.
But the configuration is usually small, right?
It's just, it's a couple of files.
Couple files, right? Okay.
And if you store that in source control, that's what you should be doing, then you're fine. You shouldn't be changing the config on the server without saving it in source control. And we really don't change the Cassandra configurations that much. Cassandra runs on Cassandra. So the system keyspace, for example, if you have a backup of that, you can literally restore that too. Okay, so well, then what about if everything is fine, but only one keyspace was messed with? You have to be able to back up the schema as well. And that's the part. This data right here is just the data for this keyspace. The schema for this keyspace is stored in the system tables, in the system keyspace. So if you do a wholesale backup and restore of the whole cluster, let's say, you know, everything, config and all the directories, then you're not really worrying about it. But if you want to start, backing up and restoring specific tables, that's when you have to do a little bit more work. So this thing basically shows you how the backups work. You know, it says, go ahead and create this data, and after you've created some data, go ahead and take a snapshot. And so snapshot is a command line tool. If you're using Op Center, there's a GUI tooling for it. And snapshots get stored in a directory under the table directory, which is the snapshots directory. And you can always find the snapshots in the snapshots directory. You can move them from that snapshots directory as well. And you can remove them as well. Sometimes when we look at a health of a cluster, we'll say, wow, you have like 100 snapshots here. Do you really need to store that many old snapshots? Or do you really need to store the snapshots on this computer? Why not put it onto S3, or why not back it up elsewhere? No tool list snapshots will give you the listing. And you can name a snapshot, and the naming of the snapshot allows you to delete a snapshot. So let's say we do a snapshot and you have like 5 key spaces and 50 tables total. When you do snapshot, it's storing a directory called snapshots under every table. So there's going to be 50 snapshot directories, right? So when you use the snapshot tool to list it and add it and remove snapshots, that's basically what allows you to manage those better. So after, let's say, you copy all your data off the machine, you can just remove the snapshot. You don't need it anymore. If you use the Linux command find, you'll see just by saying find -name snapshots in your data directory, it's telling you, hey, here it is, right? So here's a table. So here's a key space. There's 2 tables here. There's another key space, and there's 2 tables. There's 4 tables. There's 4 snapshot directories. There's another system called incremental backups. And incremental backups, what happens there is that every time there is a flush, flush means that data is in the mem tables and in the commit logs. When you do a flush, it takes everything in the commit logs and it puts it into SS tables, and it clears out the mem tables. So upon every flush, either manual or automatic, it creates a new set of SS tables with just the data that changed in a directory called backups. And you can do both. You can have snapshots running, let's say nightly, which is the snapshot of everything. And you can have incremental backups as well. So let's say you have this backups and you have the schema backed up and you just need to restore back, let's say, the data here or the data here. The process is the same. SS tables, SS tables, SS tables. These are all the same format. This is not some compressed, specialized format. It's literally the same data format, right? So what you can do is you can either copy that data back into here, and then over the time it'll start compacting, or you can selectively run what's called SS table loader. All right. So let's talk about why you would do that. So first we do a snapshot. right? Which saves SS table files somewhere, right, on the disk. And then you maybe move it elsewhere. So when we do a restore, what we're doing, we're just copying the backup from, or sorry, I'll say snapshot, from disk back to the parent table directory. And our job is done. So in theory, if this is a single node, this is pretty easy, right? But what if it's multi-node? So you do a snapshot. On each machine, it, saves the SS tables. Okay, then what about restore? So here's the gotcha. The gotcha is this will only work if you backed up from one cluster and you're trying to do a restore on a completely new cluster, the cluster has to have the same number of nodes as the original one. Because it's a one-to-one backup, right? You're backing up all the snapshots on one machine. You need to go to the other machine and be able to bring it back. Why is that? Because Cassandra is storing the metadata of where all this data belongs. And if you were to just willy-nilly move it around, you're going to lose that reference point. So here, if it's same size cluster, this works on all machines, right? That works. But different size cluster, what you do is you run SS table loader on all the data against the new cluster. Okay, but this looks like a time suck, and it is. And it actually sucks. But I want you to know what's happening when we run SS table loader. When we run SS table loader, we're actually taking that data and we're telling Cassandra to write that data as if it was coming fresh. So what Cassandra's doing is it's using the partitioner to then redirect the data to where it belongs. So this is as if replayed to the cluster, right? This is useful. And by the way, you can run many different SS tables at the same time because Cassandra is a high availability system, right? You can also run SS table loader from a remote cluster, remote instance to the cluster. Right, so if you're taking backups, let's say you take a backup here for, let's say, testing purposes, you want to do a backup of the production data and bring it to a performance cluster. If the sizes are the same, you just bring all the data back. But if the sizes are different, then we need to do this. We need to do SS table loader and load that data back. It doesn't matter if it's bigger or smaller. If it's different size cluster, we have to use something like this. So these are the fundamentals of backup and restoration. What's the next way to do this? Well, we use, let's say on Amazon, we use EBS. So there's an article by TLP about EBS volumes, how to use them. It's fairly intense. It talks to you about different tools that are available. So there's a tool that we're going to talk about in a second called, TableSnap. All right. And then it also refers to DataStax Enterprise. Actually, I'm familiar with this tool. I don't know why I didn't mention it, but there's another tool called Datos, Rubik Datos. I'll put that in the workflow here. Manual copy paste option, right? We just talked about that. And then SS table if you have a different size cluster. So, and you have to basically save your schema and everything, right? So So what they do is they explain the process, and essentially you end up with, you know, this fundamental understanding of how this stuff is backed up and how this stuff can be restored, right? Like we delete the old data, the live data, and we copy from the snapshot where it was saved to the new data directory. That's it. That's how we just did a restore. Okay. So I'm going to come down. There's another approach, which is the same thing, but with EC2 and EBS. You can do this with Azure and Google. Just you have to use their own terminology. EC2 is for the computer. EBS is for the elastic block storage. Basically, it's a mounted drive. Okay. And if you take a snapshot of that drive, it's a physical snapshot of that data. So if you just bring it back, you basically have everything. So in my experience, this EC2 EBS backup and restore is the fastest way to do backup and restore. And the reason is that everything is all in one place, including the Cassandra data. It also means that if you have snapshots, you can make a whole new cluster and restore those snapshots on the new cluster and have everything come up exactly the same. We may have to configure new IP addresses, right? It actually talks about the limitation is the cluster must be the same, data center must be the same exact configuration, same exact number of nodes. It still applies with EBS. Okay, and we can automate this stuff with automation. So it's more complicated. It's not more complicated. It just looks more complicated because there's more screenshots. But once this is in place, the snapshotting process, it's much faster. Okay. Now, this last approach, you can do this manually, meaning you take the snapshots and you upload it to S3 or Google file system or Azure, you know, whatever that file system is called. And your process to restore is still the same. You still have to copy the stuff down to the new machine. And if the size of the cluster is different, then you have to use SS table loader. So still not ideal. So let's see what tools can do for us. So Op Center, as I mentioned, is a great tool. To show you what it looks like. So you can add a backup location, and it can be either S3 or local. And actually, there's other options like Google or Azure. There are new options there. Actually, they don't have Google yet, but they have Azure. But if it's S3 compatible, which Google's is, then essentially you can back up there as well. And there's also on-premise S3 compliant file storage systems like min.io. This can write the data there as well. And when you back up, let's say you back up to local, right? It's a GUI tool. You say, I want to save stuff here, and I want to have a retention policy of, let's say, 6 weeks or 1 month. You can also throttle how fast it's writing. And mind you, if you have a NFS mount, if you've mounted a drive, this thing still works because it's local to the operating system, right? So it can be saving data to a remote mount using local FS, if that's what you're using. And then backing up data is fairly simple as well. I'm going to show you the screenshot. It's not showing the screenshot. There we go. You can see this, all the backups that are there, and you can basically go there, and then you can restore from that backup. So it does all that for you. Pretty nifty, right? So knowing that not everybody uses DataStax, or not everybody has Datos, and also knowing that not a lot of people know about these other tools, we added it to the Cassandra toolkit here, which talks about TableSnap, and it actually also has Cassandra Medusa, so you can take a look at how that's installed. So TableSnap, and let's see, TableSnap is probably the last good one that, you know, was there before Medusa came along. And, you know, TableSnap, it's just a script. Okay, it's a very simple script. It monitors like where the data is coming to. So if there's a snapshot directory that you're moving to, it then takes it and it puts it into S3. That's it. And if you didn't use any other tools, you would still have to use, you know, manually you have to get the data back and basically go restore the information using the same old school copy and paste method, as TLP was saying, or using SS Table Loader. Okay, it has all these, you know, parameters to like just use this table or just use this Keyspace. Still kind of kludgy, a lot of work involved. And then finally, Medusa, which is a relatively new product. It allows you to do single node backup, single node restore, cluster-wide in place, same cluster size. In a cluster-wide remote restore, different cluster. Clean up the backups. You can use local storage, Google Cloud, AWS, via this libcloud library. And then there's other storage providers that can be added to. Let's see what libcloud has. So libcloud has providers for all of these different cloud platforms, including DigitalOcean, which we use, Amazon, which we use, Google Cloud, which we use, and I think they're just not putting Microsoft, but yeah, Azure as well. It's quite a lot of providers that if you use Medusa, you can back up to any of these things. Support for clusters using single tokens or vNode. This is important. And it can do full or incremental backups. Caveat is that it can't do deployments with multiple data folders. So sometimes when you configure Cassandra and you're running out of space on one disk, you add another disk, and you say, here's another data directory. So it doesn't really work that well there. This tool, it's installed, right? And it's got configurations. And when you do a backup, you can give it a bunch of different things, like which mode to do. But what it's doing is, from one machine, it's going to grab everything. And then it can save it somewhere, and then it can bring it back and then restore it for you. Now, it doesn't have a beautiful interface. It's much more operable than any of the other solutions out there. And since it's command line, we can automate it via Ansible. You can run it manually using parallel SSH, or my favorite is Movax term. And then, cron tab is to run it all the time. And there's another tool called C-star, which is basically like run this, Cassandra command on all the machines. So, if we're not aware of the Cassandra world, C-star basically, you run a command and you're able to run that command on the whole cluster without having to know the whole cluster. So it's actually worth, looking into for other reasons, not just for, backup and restore. So to recap, we try to avoid disasters by having multiple regions, multiple availability zones. And the reason we have backup and restore is because people make mistakes or other folks may come and delete data. How are you going to restore from that? And by the way, it's not just that. Sometimes machines go down. That's fine. That's part and parcel of the whole high availability distributed system. So if you're using Amazon EBS, let's say a computer just dies, and you restore it with the same config, and you say, let's bootstrap this node from all the data from the other nodes, right? That streams the data from the missing data from all the other nodes. Well, this EBS snapshot solution can be used to just bring up that one node way quicker, like within 15 minutes, you can have all the data back. And actually, if you did have the snapshot for that one machine, even if you didn't have EBS snapshot, you could bring back that one machine, copy the snapshot of data for that machine back to that data directories, and the node won't have to catch up as much because it'll have the majority of the data there.
So you only really need to get from one node or load a backup that happened from one node. You don't have to worry about multiple.
No. You need to get it. You should get it from all the nodes.
Oh, okay. You should get it from all. Okay.
When we make a cluster, we say replication factor. So some of the nodes have data for one part of. Yeah,
they have only one part. Yeah, okay.
But there's 3 copies of it. So what I was saying here was, if you lose a computer and you have either the EBS snapshot or the actual Cassandra snapshot for just that one machine, you can bring it back faster. If you didn't have it and you're just relying on disaster avoidance, then it'll stream the data from the other nodes.
So basically, every single time you do a Cassandra deployment, you should have a backup strategy, some kind of backup strategy. Okay, yeah, that's what I thought.
And here's a strategy that one of our clients uses, and I guess I'll just say scenario, right? Here's a scenario. So what they'll do is they'll have, here's a cluster. We'll just call it cluster 1. Then they have a DC1 for data, and then they'll have DC1 backup. Okay, just bear with me. They have DC2 data, and they have DC2 backup. DC3 data, DC3 backup. And there's basically, in the Keyspace, we say, store 3 replicas here, right? 3 replication factor. But on here, there are, let's say, 6 nodes, 3 RF, 1 node, 1 RF. And that's kind of like, on all the backup nodes, that's what it is. All right, so what is this doing? These 3 data centers are used for the actual in and out of the data. And the data is getting spread around the different nodes. Right, so 1, 2, 3, 4, 5, 6. But in this one, there's only 1 node. Same thing here. Same thing here. only one node here, and only one node here. Okay? So when we have a replication factor of 3, that means there's 3 copies of the data. If there were only 3 nodes, each machine would have 100% of the data, just kind of like, you know, that's how it works. But because we have 6 nodes, there's 50% of the data here, right? So let's just say 50%, 50%, 50%, 50%. And that's how it is. But on this node, 100% of the data is there. So if we were to lose more than 2 replicas here, 3 replicas, there's a potential that we're gonna lose data completely. This one node has 100% of the data. And we can rebuild this data center from here. We'll just say repair, and it'll synchronize everything. Another thing that we can do here, if we just back up and restore if we just back up this node right here, we will be backing up all the data. That makes sense? And you can keep adding nodes. I'm going to get rid of these. So we have 9 nodes here. Let me scale this one as well. Right? This one node data center will continue having 100% of the data. And so will this one, and so will this one. And if we have, so let's say DC1, we're going to keep in US East, as well as the backup. We'll put this in US West, as well as the backup data center. We'll put this in Singapore, as well as the backup. And we can be backing up full data from here in Singapore, from here in the West Coast, and from here in the East Coast. If there's a disaster, catastrophic disaster, all of our data is backed up here. All we would need to do is bring up this backup node in this backup data center and start adding new data centers. And it will kind of synchronize all the data. So this scenario, I think it's kind of like a hack. Remember why Cassandra was built. It was created so that we could distribute terabytes upon petabytes of data across different nodes. So if you can imagine, if this cluster continues getting bigger and bigger, the disk on this computer will get bigger and bigger. And we may end up having problems where we're having performance issues with this particular node, because the disk isn't able to catch up. Or even if you attach a very large, elastic block storage, a disk that can continue growing bigger and bigger, eventually you're going to hit a limit and you're going to have to mount a S3 bucket, but that will be slow. So data that's coming into the cluster won't be able to be streamed and replicated to this data center as fast. So there's an upper bound for this strategy. Eric, as you were asking, can you just back up one machine? If you do this, if you have a data center that has 100% of the data, then you can just back up one machine and you'll have all the data. But in this case, you technically have to back up all the nodes individually. Make sense?
Hey Rahul, in this case, like they keep on adding the space to the disk because it's one node, right? And let's suppose there are terabytes and terabytes of data.
So which are you talking about, the DC1 backup here?
Yeah.
Yeah. If you keep adding nodes, then this will continue getting bigger, right? And so there's an upper bound. We can't go beyond a certain amount of data per, for this, right? But still, you could end up doing this. You have, let's say, 3 nodes, but still 1 replication factor, because we're not using this for high speed, right? We're just completely copying the data.
Yeah, that makes sense.
And why do this? It's just backing up all of the data, saving it to S3, bringing it back, and restoring it can be a very cumbersome process. But if we just backed up from here, we have the complete data on basically one computer for a Keyspace, for everything. So technically, we could back up everything here for, let's say, for performance testing purposes, right? We can just keep a fresh backup of all the data for production in one place. And anytime we have to do a restoration, we can selectively restore a table or a Keyspace using SS Table Loader from here. Okay, anyways, this is a strategy, it's a scenario. Not a lot of people use this, but it's been working in a few different cases. But there's various different scenarios. So there's, let's say, cluster 2. So in cluster 2, we'll have DC1, which is data, DC2, which is stream, DC3, which is, we'll call this transactions. We'll call this analytics. And I'm just naming it out there, but basically this is where the data is going to be, reads, heavy, writes, okay? And we can have, let's say, 9 nodes here, but then DC2 analytics, which is, occasional reads plus writes, let's say for machine learning. And we only need to have 3 nodes, which is very big. So we don't have to do snapshots here. As long as the data is getting replicated here, we can just do the snapshots here. So best case scenario to worst case scenario. Best case scenario is you're doing this.
I'm not sure I understand.
Of course not, Siri. The best case scenario is you're doing EBS snapshots or whatever, and you're doing this, because restoring a whole drive is more work than you need sometimes. You just want to go to the snapshot from before. And you're backing up to S3. Best case scenario, you're doing all 3. Local backup, upload to S3 or whatever distributed file system, and do a disk backup. Best of all worlds. How do we do that easily? You have Op Center as part of DataStax, and then you turn on EBS snapshots, because Op Center is taking care of this and this. The next best thing is you implement Medusa to do both this and this. And on top of that, you do EBS snapshots. EBS is expensive, so not everybody has EBS. They may just have, SSD hard drives. So in that case, you can't do this. So the next best scenario is you do backup and restore locally, backup and restore to distributed file system. Worst case scenario is actually being prepared for the worst case scenario is something like this, where you don't have access to the cloud at all, and you're doing local backups, and you're copying it to like a network mount. But this would be the fastest way to do that. Back it up locally, and you just move the whole directory over. And in an on-premise data center, this actually starts to look better and better and better. The other thought that I had with this is that if you're in an on-premise data center with private cloud technologies, you can start to do snapshots of the disk, and they do. VMware supports that. So technically, you can do that on an on-premise data center as well. There's so many different strategies, but ultimately it all comes down to this, that the data is backed up as the native format. Number one thing to remember about DataStax, Cassandra, which is part of DataStax. is the data that you're storing the data in SS tables, that file is the same exact file in the snapshot form as it is in the backup form. As long as you can save that elsewhere and copy and paste it back, you can restore it. There's no special restore command. The only other restore command is if your cluster is differently sized, then you use SS table loader to then bring that back. Any questions? I just saved all of these links as well as a bunch of the videos on Cassandra.Link. The next time it's built, it'll come up here. You can actually look for backup, restore, a bunch of strategies on backup restore. There's another tool called Cassandra Backup by Instacluster. Let's see what it does. Backup of and restore of SS tables and of commit logs. Seems pretty similar to kind of TableSnap, but what it's, oh, and you can save it to S3 and restore from S3. So it's kind of like Medusa. I'll go ahead and put this in my list here. All right. But more resources will be added to Cassandra.Link. And you can also, I think it should just be up here somewhere. Unless it's getting filtered out for some reason. Note to self, add a filter to the tag view. I'm gonna rig it. I'm just gonna look for a backup dash restore. Looks like there's only one item here that I've added, but the next time you see it, you'll see a bunch of new stuff. You can always search for backup. Cool. All right, guys, that's it for today. I want to respect your time. It is 1 o'clock Eastern, and we are good to go. See you guys next time, same place, same time, same location on the internet. Take care.
Thanks, Thank you.